Hello and welcome to our lesson on chapter number 2 for business statistics. Today we're going to be talking about the visual aspects to summarizing data, mainly graphs, charts, and tables. And that's about all there is to it. So we're going to be very focused on the visual today. And a lot of the examples I'm going to do are going to be better represented using technology. So most of the graphs and charts I'm going to show you today, I would not recommend doing by hand. We're going to learn how to use them using tech. And it's going to be a little more Minitab heavy chapter because of that. And you'll see that as we get into it. So there's going to be a little less meat to this. However, when you watch your Minitab video lesson, you'll see that, oh yeah, I am going to use technology to do this. And then you'll see where everything comes in the chapter. So our outcome list today looks a little strange. You may immediately draw your eyes to the bottom 3 outcomes, which I have crossed out because they are not done at this time in this course, and a couple of them they're not done in this course at all. So outcome number 7, which is about scatter diagrams, I do in chapter 14 just because chapter 14 is the chapter that requires scatter diagrams. So I decided it was a little silly to do it in chapter 2 when you are not going to be using it for another 13 weeks. And I figured by the time those 13 weeks roll around, you will have forgotten them. So I moved them to a more logical location. And if you're somebody who reads the book, it's important to note this so you don't read through these sections and, cover stuff you don't need to. The next thing I have crossed out is outcome number 6, just because when it comes to line charts, also known as time series charts, well, they're for doing time series, which is done in Stats 2, not in Stat 1. So we're not covering that here. It gets covered in Stats 2. Outcome 5 we've crossed out simply because stem and leaf diagrams aren't really used much anymore. They're really only appropriate for small data sets. And most modern businesses just don't use small data sets. Everything is large and in charge, and we live in the land of big data. So unfortunately, we don't really use stem and leaf plots anymore, so we're just not going to do them at all. Anyway, next up, you'll notice the 4 that are not crossed off are in kind of a weird order. So we're going to be learning about distributions and histograms and bar charts, and these are all one variable. And the joint frequency distributions, they're joining 2 variables together. So they're the only 2 variable topic. So I put that at the end because I feel like it flows a little better because these are all the same type. And then the third one is just sort of an extension of the other 2. So it goes 1, 2, 4, 3. Just to let you know, I'm a little out of order compared to your text. Let's get this party started. We're going to start with frequency distributions. So we want to use frequency distributions to summarize the information before us. I have an example down below using students' ages. So as you look at this, you'll notice like, oh, this is a pretty short list. So, if I just wanted to describe what students' ages looked like from this group, I could really just look through this and tell because it's pretty small. Now, if you were working for, say, like the HR department of a large company and you had to look at the ages of 10,000 employees, just looking through the list and saying, oh, what is a typical employee's age is incredibly not what you want to do. Reading through 10,000 lines of data and trying to remember how it looks just sounds like something that you shouldn't bother with. And that's why we want frequency distributions. Frequency distributions really do 2 things for you. They tell you what kind of values do I see, these guys, and then how often they occur. Frequency, how frequent does it happen? So for instance, there's 7 categories here, and they are distinct because they have no overlap. That's what distinct means. They share nothing in common. And you can see that apparently I have some, much younger students. Sorry, I have a yawn I was trying to stifle. And then one a student who's a little bit older than the rest. So this is, kind of interesting, but clearly I have more of the younger ages than the older. Now, when you're making frequency distributions for this data, I was able to use different categories to represent my groupings of how I wanted to summarize this. When you have more options, so more than 7 possibilities, you're going to want to form distinct classes, and we'll see some examples of this as we move forward. Alrighty, so here's a rather large set of data. This table is taken from your book. It's the Dallas Walmart data, if you were wondering, and you can access that in your student data if you want to, or if you want to look at the textbook. But anyway, this represents the number of different product categories people purchased from Walmart in Dallas, and it was I believe this was a random sample. Sorry, I'm looking over at the book to make sure. Anyway, so basically they were looking at, how many different categories of products do people usually purchase from they are purchasing items in our store, and we want to create a frequency distribution for this. So as you look through this, the only one that's about easy to spot are like the 10s and 11s because they're the only 2-digit ones in here, and everything else looks kind of like gobbledygook. We want to let a computer do this for us, and that's exactly what I did. So it arranges the different product categories. Notice this is nice and simple because I didn't have to make classes, and then count how many of each there were. So for instance, it looks like most people buy between 4 and 6 different categories worth of items. And it's rather unusual because 9 seems a little bigger than the rest too. Fun times. Alrighty. So what I've done previously is what's called discrete data, also known as countable data. It's, where I have whole numbers of things and I can count how many they are. For instance, people are countable because I can't have half a person and have them be alive. You're either a person that's whole or not whole. Yeah, you get the idea. It's stuff you can count. How many floors a building has, Oh, no, wait, there are half-story houses. Crap. I maybe messed up there a little. How about how many rooms you have in your house? Like how many bedrooms there are? 1, 2, 3, 4, or 1, 2, that kind of thing. You can count them. Examples of this would be student age. The reason we can use age as discrete is because, human adults don't count the number of months they are or partial parts of years they are. So for instance, when your friend wants to have their half birthday, you should tell them, don't do that. You're a crazy person. You should get over that, once you get over 5, honestly. And don't let your friends, like my sister, call their baby a 38-month-old. They're 3. Shut up. I'm diatribing now a little bit too much. Anyway, the Walmart example we just did, number of, late deliveries per month, something you can count. You get the idea. Others, question mark, because I'm real confident myself. Here's some more discrete data. Here's late deliveries per month. So with this one, it's a smaller data set, so it would be pretty easy for you to go through and count the number of values that are in there. So these are just the steps behind this if you were to do it by hand. Again, I'm not going to do this by hand, so I'm going through this kind of quickly. So first step, list everything. Second step, count the stuff. Ooh, I think you could have came up with these steps yourself. Third step, if you're going to do relative frequency, you need to get the total of the number of items that there are. That's also known as N, and take each frequency and divide it by that total. So you're getting a proportion that represents what proportion of the whole this category has. So for our number of late items data, that would look like the following. Yay. So how you get the relative frequency is you'll take the frequency and divide by the total. Yay. Not too bad. So usually with relative frequency, you'll see these represented 2 different ways. The first one is the decimal equivalent, and the second one is the percentage. So I've listed both on here for you. Be careful, and some of your homework questions are very specific when creating relative frequency. Some of the questions are specifically going to want percentages. Some of them are going to specifically want decimals. So just, watch out for the percent symbol. Pay close attention when you're doing relative frequency because both representations are correct, but using online homework, occasionally it's a little more picky than like I would be for your assignments. So like in your Minitab assignment, I really won't care which one you're using as long as it's one of the appropriate ones, either decimals or percentages. Cool. Alrighty, here's another example. This was also stolen from your book because I was really lazy putting this together today. Oops. An advertiser asked 200 customers how many days per week they daily read the newspaper. Unsurprisingly, 0 seems to be the highest frequency. So notice you should add these all up and they should add up to 200. And then when you do the relative frequency, you just take the amount of frequency for that category and divide by the total number and you will get stuff like this. Now be careful with your rounding here. I included this on this example and not on the last one, but your relative frequency should add to 1, which is equivalent to 100% if you're writing this as percentages. You might have to be careful with your rounding when it comes to that. Rounding, it'll get you every time. Don't round like the devil. Yeah, you get the point. All right. So what if I have some more complicated data, such as continuous data, things like time or length or weight or anything that has units that could be continuous. Anything involving money is considered continuous. So with this, you can't count the amount that it has because usually it's could be any value in a certain range of values. So what we do instead is we create our own little ranges by grouping data, and we call those frequency classes. Good times. Or, oh wait, your book just calls them classes. Classes! I'm awesome at this. All right, so a couple things about classes. Classes need to be mutually exclusive, which is just a fancy way to say they are not overlapping, which means they both are exclusive to each other, hence mutually exclusive. So they can't have any outcomes in common. This makes it so that nobody in your data or no objects in your data are counted more than once, because that seems like it would not represent your data very well. All right. Classes must be all-inclusive, so it must account for all of the values in the data, and that way you're not excluding anybody again, and they should be equal in width. Unequal widths often create a disproportionate picture of what your data looks like. This is why when it comes to drawing the scale on stuff, we want to start with 0 and not a specific value, because it creates a disparaged amount of comparison data, which means that stuff seems taller or shorter than it should be in comparison to the other data if you don't start at 0. Anyway, and we want to try to avoid having empty stuff. That's not always possible, and the empty one just isn't as important. Sometimes it's unavoidable, but the other three are very important. If you use Minitab to do your classes, you'll never have this problem, just so you know. Here we go. So, first step, determine the number of classes. Establish your class widths from those classes. You just take the max and the min of the data and divide by the number you intend to do. Then create your boundaries for each class, just to figure out what's the biggest value and smallest value that are included in that class, and then determine the frequency for each class. So count how many are in each of your classes that you have. And then if you want to, you can change it into relative frequency as well. So that seems like a bunch of words. Let's see how it's done. Again, you won't do this by hand. You will use Minitab to do it. But just in case you're one of those, what's a word for this? Traditionalist, and you want to do it by hand. Here's how it's done. Oh, I forgot this was here. I meant to put this later. Awesome. Well, that throws me off my game. How many classes should you have? Well, not too many. If you use too many, sometimes it can make it appear to have a pattern or no pattern whatsoever when there is a pattern. And you also frequently will have gaps if you use too many. So this one is definitely too many because it looks like there's some sort of large frequency between these groups and these groups, but when you group this into a smaller number like 6, it actually shows that there's actually 2 distinct parts to this, which is interesting. It just is not a good indicator of shape. It makes it really hard to tell shape. If you use too few, it's like this. That's like saying the temperature tomorrow is going to be somewhere between 0 and 200 degrees. It's just not useful. You don't see any patterns in it. And patterns you're going to see become more important when we start talking about shape of data and when things are normal. So, you know, if you feel like you struggle with this, we do have some rules of thumb for that. Like, how many classes should I have? Most people try between 5 and 20. I like to keep mine somewhere between 7 and 12. I'm a little more restrictive than they are. And a good rule of thumb is that your number of classes should be 2 to some power. This keeps it even and balanced. That's why it looks like that, just so you know. So usually we determine class width by deciding our number of classes, taking the largest value, the maximum, subtract the minimum value, takes your range and divides it into your classes to determine width. Woo. So let's do an example of this. So here's some data. Yeah, this is from Homeland Security about Lincoln Communications. This is mostly when you're looking to, this is unfortunate because we have a hurricane coming, not in Michigan, but in other parts of the country. But when you're looking to establish communications for protocol when it comes to handling disasters, not necessarily a hurricane, you know, it's better to have a short amount of time, but let's see how things go. So this is taken from 72 different cities. This is arranged by size, which is nice. How would you approach this problem? Well, there's 72 cities, so we're going to start there. We're going to start by determining our number of classes. So I'm going to use the 2k to the n rule. Now, I know my 2 powers pretty well. That doesn't mean I have them memorized. I know that 2 to the 4th is 16 and 2 to the 5th is 64. And I know it's got to be bigger than 5 because Well, the lowest number I want to do is 5. So I actually started this by looking at 6 to see when I would get something bigger than 72, because that's the number of items I have. And here's what you discover. If you do 2 to the 6th, oh, that one's 64. Oh, I did 4 to the power. Okay, nope, screwed up. I'm not re-recording this. You can't make me. That one's too small because you got 64, which is smaller than the 72 number of cities. So then I tried the one that was next, 2 to the 7th, and that's 128, and that's bigger. So that means I'm going to use 7 classes in this. So then next up, I got to find the minimum value and the maximum value, subtract them from each other, and divide by 7 to get my class width. So here's how that's done. Woohoo! Minimum, maximum, highest number. This is the thing I just said. Oh, that's awesome. So obviously you can go back and look at the data and see that there's the max, there's the min, dividing it by 7 because that's how many I decided I was going to have. So it's 208. So usually what we do with this is it's usually not a nice number, so we'll round it to make it look something nicer. So I picked 225. If you would have picked 210 or 200, it would not have made a big difference. I just picked 225 because I generally like how powers of 5 look. Feel free to judge me for that one. Why am I so sarcastic today? Brrr. Anyway, so my boundaries are going to look like the following for my classes. I'm going to start at 0, because you should start at 0, go up to 225, and then from 225 to 450. So I've described these out with words to help you understand. So here, my class goes from 0 to 225, and it's got to be stuff under 225. If it was the exact value of 225, I would actually put it in the next class up. Does that make sense? If not, here's another version of that. Woohoo! So notice the open-closed boundaries for these. So hopefully you remember interval notation. This means that I'm going to start at 0 and go up to 225, including 225, and anything bigger than it's going to go into the next column. And so what I did is I went through and I counted how many of each of those appeared in those ranges. It's very important that my the value here be smaller than the minimum. And if you remember, the smallest value in there was 32, and that my maximum be larger than the largest value present in the data, which was 1492. So we're good. I've covered the entire range. Nobody overlaps. And that's about it. You will see some textbooks that write, sorry, I'm yawning, specific values in here about what decimal they're rounding up to and down to. That's not so important, since we're dealing with whole seconds. Anyway. And here is a histogram produced using Minitab of that data. So I had Minitab automatically produce this and just told it I wanted 7 bars. Do you see a shape? Woohoo, it looks like it peaks right about here. And then I've got a couple people that are, doing a lot worse time-wise for setup. And a couple people that are doing a lot better when it comes to time, because you want less linking time. And then it looks like the average is probably going to be somewhere around 1,000-ish seconds, which isn't too bad. Yep. So we're going to look at how to do this with Minitab in your Minitab lessons this week. Woohoo! So here's an example that I put together because I wanted you to see another way you might see these visualized. So this one in particular likes to use the values itself on the bottom for its ranges, and there are a couple of them like this in some different texts and designs. I believe that when you're using Excel, I had to think about that one for a second, they just mark the tick marks here with like 169, and you're supposed to know that it's rounded to the bottom one, rather than, intervals like this. But the interval notation is kind of nice because I feel like it's more specific. I actually don't like the shape of this one. I feel like 12 sort of fools you a little bit because you'll see one that's smaller next, because it makes it seem like these heights, this 79 inches and 98 inches, are the more common ones. But then when you look at it using fewer groups, it actually comes out to a kind of nice shape. Like I would say it looks like to me the average height of an NBA player is right about here, somewhere between, 217 and 237. And you might look at this and think, oh, well, that's a pretty big range. It's 20. This is weights, not heights. Oops. I should go back and re-record the other one. I'm not gonna. Here we go. So why do we look at histograms? Histograms of quantitative data tell us lots of information about what's going on. The first one it's going to tell us is the center. What's the typical value or most frequent occurring value in my data set? What's the spread? What range of values should I expect my data to cover? And then lastly, it should display shape. Here we go. So here's the same shape, but different centers. Woohoo! So centered about here, here, and here. So it actually shows you that, oh, on average, the blue group is much higher than the green groups. Trippy, right? And then same center, different spread, different shapes. And this is kind of interesting because one of the things that this tells you is although these are all the same on average, there's a lot more variation in group C. So if these were like, say, test scores, which we're going to pretend we're on which doesn't make sense for these values, test scores, honestly, you would want to be a part of group B because, what's your chances of possibilities? Well, maybe like 350 to almost 500. The range is much smaller. You wouldn't want to be in group C because there's a lot more variation here. A lot of people did worse and a lot of people did better too, but you have like a chance of being much, much worse compared to the average. And then A is usually what you see in grade distributions. Like you get most people around the same score, a couple people higher, a couple people lower, but you'd want to be in group B because that's the least amount of variation or spread present in the group, in the grade. There we go, right word. Whew. Let's talk about cumulative frequency and cumulative relative frequency. I actually don't like cumulative frequency distributions. I think they're a little bit hard for people to read and understand. The average person looks at them like they're gobbledygook, and I prefer clarity when it comes to visuals. But that being said, you might run into a group of people that really, really like them in your work environment in the future. Who knows what the future holds? Good times, hopefully. But we're going to show you these anyway, but again, they're not as popular, and I'm going to show you the most popular of the unpopular graphs. It's called an ogive. It has a cool name, so of course we're going to talk about it. So the most important part about cumulative frequency and relative frequency, they are similar to frequency and relative frequency, but one slight difference. They're cumulative, which if you're trying to think of what this word means, think of it like accumulate. When the snow is accumulating on the ground, it's stacking on top of each other. So really what this is doing is adding up to the total. So it's going to add up to the total, or in the relative frequencies class, add up to 1 or 100%, depending on if you're doing decimals or percentages. Alrighty, so here's an example for you. So if I had DVD movies, people owned. Do people even know? I thought Blu-ray was the thing now. I own a lot of digital movies, so I would not do it this way. Anyway, so here's your classes, and then I have my frequency right here. So starting from frequency, if you were just going to produce relative frequency, you'd take this, you'd divide by 230, so 60 divided by 230, and then getting those values and rounding them. So if you do cumulative frequency, to get to the next class, you're going to add the total frequency to the previous class. So how did I get 110? I added 60. I took 60 and added 50 to get the 110. And then for the next class, there's 45 more, so you add. And you just keep adding and adding and adding the frequencies previously until you get the total. Similarly, for cumulative frequency, you're just adding the previous class on top of it. So it's like, oh, I'm just stacking on top. I'm accumulating. That's why it's called cumulative frequency. A word's hard to say. All right, so this looks a little weird. So a graph that displays frequency. Oh, I've already talked about these. Yeah. So frequency diagram we've already seen. Bam. Moving on. Why is this here? This is in the wrong spot. Well, that's craptastic. Yep. Frequency is a good time. Oh, I remember why this is here. I'm such a good teacher. Here's the Walmart one again. Yay. Here's where I want to get to. Ogives. So using the data, where is this from? It's emergency response times. That's what this one's from. So these are a bunch of emergency response calls. I believe there were something like over 1,000 of them. I can just cheat and look right there. Oops, I'm a good teacher. And when you look at this, you can create frequency or relative frequency, which is why I talked about those two before and then forgot that that was my goal there. Yep. So if you just did regular frequency, you'd get this lovely histogram. Notice it has this sort of nice sort of symmetric shape. One side kind of looks like the other. My peak is almost dead center. You know, it's got kind of a nice shape, shows the range pretty well. You get your center pretty easily, which is everything we want in a histogram. And then they're like, no, 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 let's create the ogive. So the ogive, notice it's different because it's showing, the regular histogram shows the relative frequency, and here we're showing cumulative frequency. So it's like I stack these bricks on top of each other to figure out its frequency, and it's going to be right here. So what's interesting about the ogive here is it gives you a nice curve, which you notice it's symmetric too, just like the original. Actually, you know what, let me go to my next slide, because my next slide is a close-up of the ogive. There we go. Nice and symmetric, just like the histogram was. Now, the big thing about the ogive is it does help you see where you have the greatest amount of change. The easiest way to see that is to see who has the steepest slope. So that tells you where the greatest amount of change has happened. So in particular, notice I've got a very steep slope right here. And that tells me that in particular the jump from the category before to this category is quite steep. And I think my next steepest is right next to it too, although that one's almost parallel to that one. So it tells you that I start out growing slowly, and then I've got a lot of growth in the middle, and then the same thing happening on the other side. It's slowing down in growth. And that's telling you this guy looks pretty symmetric, and my biggest part appears to happen in the middle. So you can still see the same behavior, but it helps you see where you see your greatest change a little bit easier, I would say. All right, here's the ogive of the player weights, in case you were wondering. So what's interesting about this one is it's not quite symmetric, and I see the greatest change happening on the upper end, which would be on the right-handed side of the histogram, which is exactly what's happening here. I'm getting some change, and then I've got a steep change happening here, and it's slowing down and going, it's not slowing down, it's going down much faster than the other one, so that's why this one's slowly growing, but not really changing that much. Comparing an ogive to a histogram is a little difficult, so if you struggle with it, don't worry, ogives aren't that popular. So we've just finished talking about quantitative data. We did histograms and we did ogives. I'm going to switch over to doing categorical, also known as qualitative data, which are bar charts and pie charts. So I use the word categorical data here because one, your book does. They decidedly suddenly didn't want to do qualitative for some reason. Don't worry, I didn't write this. But I like it because here we're going to be doing charts, and notice charts start with C and go with categorical data. So that's how you're going to know which type of graph should I do for categorical? Charts. They all start with C, yo. There are other quantitative data, diagrams, and graphs that we will be doing, but these are the only ones in Chapter 2. Moving on. All right, so what are bar charts? Bar charts use bars to represent how frequent or how relatively frequent each category occurs. So if you're having a hard time with categories, if I asked you all a question like, oh, what's your favorite pet? And then recorded the frequency of how your answers went, the answers or possible answers you and your classmates could have given, those make categories. So maybe you said dog, maybe you said cat, maybe you're me and you said bird. There's 3 outputs that could possibly be categories for you. Maybe it's horse, maybe it's turtle. I say turtle weird. Maybe it's fish, in which case, how is fish that interesting? I don't know. It's not like you can interact with them. Why am I getting distracted? Anyway, so categories are made by looking at groups of outcomes and possible outcomes. Categories are always going to be countable when it comes to categorical data. Anyway, so like I said, like the height of each bar, if you're doing a vertical one or if you're doing a horizontal one, it'll be the length of each bar represents how frequent or relatively frequent each observation is. You've probably seen a bar chart before. Here's one for you. So this is from the S&P data from your textbook for the different years. Oh boy. And it's just the S&P ratio. So notice each of the bars' heights represents relatively like where their values were at for the ratio for each of the different years. Good times. Here's another vertical one. Woohoo! So here our different categories are not years anymore. So it's just been, you know, taken and put in this order. So what's interesting is when it comes to Minitab and accessing these, this is put in what we call decreasing order, so the biggest one's first down to the smallest one. And if you were, wanting to see who was the largest, this would be a great way to represent this because the bigger groups are all on one side and you don't care so much about these guys. You can also make this do alphabetical order if that's who you are and you like to have things nice and organized in that way. You can also put it in increasing order, so it's just different ways for different people. And I keep writing the word vertical up here. It's the upsy downsy ones, not the lefty righties. Woohoo! Here's a lefty righty for you. Now, this one is very interesting because it's what we call a clustered or grouped bar chart, because I have two different bars representing one variable, but each bar represents a different time period for that variable. And what this will allow you to do is allow you to compare not only amongst the companies, but also amongst the years what's happening to see if there's been any change. Now, I personally would not use a bar chart for this one in particular, just because I feel like there are too many bars happening here. It's a little bit hard to read, but it's not too bad. I've seen worse for sure. This one being vertical wouldn't have made much of a difference, but this one's kind of nice because it allows you to talk about what the percent difference was from one year to the next, along with comparing the different companies to each other. Here's a vertical version of the same thing. So here you wouldn't talk about percent difference because your second variable is gender, which isn't about change, it's about two different possibilities. So here we've got our different years and we've got our cluster based on being male or female. Woohoo! And once again, disappointment is the name of the game for me and my gender. Anyway. One important thing to notice on this table is I did start at 0, and that's very important because if we would have started at like 30,000, this gap would seem much larger than what it actually is. Again, you really should start at 0, especially if you have data that has a true 0. All right, pie charts. Woohoo! Don't worry, I won't judge you on how good you are at drawing circles. Not my job. That's your art teacher's job. Professor. Whatever. I'm sure you've seen this before. They basically take a circle and it represents the whole part of the data, and then you split up the circle into parts, making slices of pie, based on the size for each of those classes or categories within the whole. One thing to watch out with pie charts is they're really meant to do relative frequency, not frequency. Since you're doing percentages or parts out of a whole, it's much more natural to do relative frequency than it is to do frequency. Not to say that you can, you just really shouldn't, because it's parts out of a whole. It's a fraction. It makes more sense to do a decimal or a percent. I'll show you how bad this goes when we try to do it without one. Here we go. So step 1, make your categories. Step 2, do some division. Step 3, draw it. I really summarized that quickly. Sorry. Here we go. Yeah. So I don't know if you're interested in golf. I used to be really good at it. I haven't played in a long time. Let it go. So this was based on a survey where they asked golfers what was the thing that they felt really helped them the most when it comes to determining their driving distance off the tee. So if you're unfamiliar with golf, this is like the first hit they do before they start chasing the ball all over the place and trying to put it in the hole. Is that simple enough? I hope it is. In case you're not used to this sport, it's a sport where they put a ball on a little stick called a tee and then hit it with a club and try to get it in a hole that's really far away on grass. I should not summarize sports. Here we go. So we took frequency, and what I did here is I added these all up and divided by the total to get the relative frequency, which we've reported in the pie. And this is also very typical of a pie chart. They're usually color-coded. For those of you that are colorblind, when I usually do these, I usually do them as a pattern. This one was from your textbook, so I did not do a pattern. So I'll do like one striped, one dotted, and one not dotted. And then I try to do like different patterns to help you see who is who, because obviously using colors isn't always that great. And also keep that in mind if you're ever presenting, not to choose too many colors that are difficult for colorblind individuals to see, because you never know in your audience if you've got somebody who needs a better visual for that reason. And this is also a really good pie chart because it not only tells you what categories each of them are, but it gives you the percentage each part is. And I'll show you how to do that on Minitab as well. Now you'll notice in here you have one group that's really small compared to the others, and that's shaft length. And often when you're doing pie charts, you'll have a problem where some of the groups are small, so small or infrequent that they really muck up the diagram. And usually when that happens, what you'll want to do is you'll want to group them together and call them an other category or a grouped category. So if shaft length would have been much smaller, I might have grouped it together with something else like shaft material and called that shaft length or material, and so forth. Or if I had 3 or 4 that were all, random responses that didn't seem to, match anybody else, and they were really small, like 0.3%, I'd group them together and call them other. Alrighty, so what do you think of this pie chart? It's a little bit better. I like the use of blues and oranges because those are usually a little easier for people that are colorblind to see. This one not only gives you the percentage, but it also gives you the total, which is useful. This is the kind of one you'll see coming out of Excel, if you like Excel. Sorry, I had to pause. I had a cough. And you look at this one, and at first glance, it seems just fine. And then you look a little deeper, and you add up all these percentages, and you realize it's only 98%. So either there was an other group that they missed and should have included, or it appears that they rounded too much. So if this is the case, you notice something like this where they end up either over 100 or under 100, you want to redo your rounding and do it a little bit differently, or check to see that if you need another category. So here is another example of sort of a poor use of a pie chart. So here I've got universities and tax dollars, and somebody took this, just totaled it, and made it into a pie chart because that seems normal, right? Think about this real carefully. What does your total represent in that? It would be total tuition dollars you would pay to going to 4 different colleges at once. And then you divided and made a pie chart. So in this case, there's a bit of a problem because really you shouldn't use a pie chart for quantitative data. And this is clearly quantitative data. I'm looking at money that's not different, like divisions of the same sources of income like the graph we had previous. Here, the money represents totally different categories from different universities. It just doesn't make any sense to do this as a pie chart because it is, well, it's interval data. It doesn't make any sense. So in particular, be careful. Check yourself before you wreck yourself on your data type and whether or not it would make sense to total that data type. And that'll tell you whether or not you can make a pie chart. So hopefully you'll remember this morning and then you won't make the mistake that I purposely made here. I also hate that my 2 blues look the same, but what are you going to do? So we make ourselves a table. So you take your one variable and make it your rows. So here's my charge type, making rows. And then the other one is going to make your columns. So parking garage 1 or 2. So individuals that fall in this box are going to be ones that charged and were in parking lot number 1. Or sorry, parking garage number 1. And down here will still be parking garage number 1, but ones who paid cash. And similarly for here and here. I've done this in Excel, so I've got this weird blank row in between. Usually when we do this on Word, what I'll do is I'll merge them so that you don't have an extra blank box down below. And I'm also going to include some totals for this. So what you'd do is you'd go through the data, and I'm going to show you how to make Minitab do this because I would not do this by hand, honestly, and add up all the different groupings. And here's how it would look. So it's going to count the joint probability, so what they are together. So you count all the people that charged and were in 1, there were 40, all the people that were in 1 and cash, and so on and so forth. Here's a better version of this. Woohoo! So I've drawn on this in 2 different ways to kind of help you out on how to read it. So first of all, again, that 40 represents peoples who did both of these things. So it's carrying 2 characteristics from 2 different variables. And then you can use the totals to look at just one variable's characteristic. So for instance, garage number 2, there were 30 people that used it. People that charged, there were 60. And in total, there were 80 overall. So it really gives you a way to sort of organize how the 2 are interacting with each other. So what you might notice is, oh yeah, overwhelming overall, people used parking garage number 1 and charged. Yeah, good times. Or you could look at this and be like, out of everyone who went parking, half of them used parking garage number 1 and charged. Good times. So, which chart should you use when? If you're dealing with a quantitative variable, overall you should be using a histogram, either the frequency or relative frequency type. If you want to accumulate either of those, you'll be using an ogive. If you want to do something with qualitative stuff, you can do a bar chart, which you can do in frequency or relative frequency, or you can do a pie chart. Although in a pie chart, you really should only use relative frequency because it helps you avoid the issue that we had with that last pie chart example where the total made no sense and you really couldn't do relative frequency. And then last but not leastly, note that if I want to do 2 variables, I should do a joint frequency distribution. So stay tuned. I know this took me a while to get through, but the mini tab section for this week is much more informative and will help you do a lot more things than watching me do these by hand because to be honest, almost nobody wants to read through a bunch of data and when they could use technology to do it for them. Woohoo! Thank you for your time and attention. Have a good day.